This is gas stoichiometry part 1. So our prompt says calcium carbonate decomposes upon heating to produce calcium oxide and carbon dioxide gas. If 10 grams of calcium carbonate are completely decomposed at a temperature of 25 degrees Celsius, which is 298 Kelvin, and a pressure of 1 atm atmosphere, what volume of carbon dioxide is produced? So first, we're going to need our balanced chemical equation, which is not given to us. So we're going to have to write it on our own. So we have calcium carbonate in solid form reacts to form calcium oxide, CaO in solid form, and CO2, carbon dioxide gas. Next thing is that we're going to have to use stoichiometry and dimensional analysis to convert our 10 grams of calcium carbonate into the moles of CO2 so that we can use in part of the ideal gas law because our following information is given in the form of the carbon dioxide. So we're going to use dimensional analysis, 10 grams of CaCO3, calcium carbonate. Molar mass is 109 grams of calcium carbonate, as well as 1 mole. So 1 mole of CaCO3 is 1 mole of CO2. And if you do the operation in your calculator, you should get 0.0999 moles of CO2. And that is the N that we're going to use. Next thing is that since now we have the N as well as all the other components, 25 degrees, 298 Kelvin is the temperature. So temperature. And then 1 atm is the pressure. We're going to substitute the following numbers: 298, 1 atmosphere, and 0.999 into PV equals nRT, ideal gas law. If we isolate and solve for the volume, which is the unknown, we have V equals nRT over P. And for R, we're going to use 0.0821 L atm over mole K. If we do some substitution, we get 0.0999 moles of CO2 multiply 0.0821 L atm mole K, as well as 298 Kelvin, all over 1.00 atm. If you do the operation in your calculator, you should get volume is equal to 244 liters. And that is our final answer. So 244 liters of carbon dioxide gas is produced. In the next video, I'm going to do another example on gas stoichiometry. So that's the part 2.